Hi there everyone, I am Maria Micaela Zaysiscar, a BS Ed Science 4 student. In this presentation, we will be discussing a fundamental principle of fluid mechanics, the Pascal's principle. This principle has wide-ranging applications in various engineering fields, from hydraulic systems to medical devices. To start with, let us all be guided by our learning objectives. First, explain Pascal's principle and how pressure is transmitted equally in all directions through a fluid in a confined space. Second, apply Pascal's principle to calculate the forces and areas in hydraulic systems. And lastly, recognize the significance of Pascal's principle in real-world applications. Alright, so let's begin by examining the core concept of this principle. Pascal's principle, which is named after the French mathematician Blaise Pascal, states that when a pressure is applied to a confined fluid, the pressure is transmitted equally and undiminished in all directions throughout the fluid. This concept is crucial in understanding how fluids behave under pressure and allows us to design machines and systems that can transmit forces efficiently. To illustrate, imagine we have a sealed container filled with a fluid, such as water or oil. When a force is applied to the fluid through a piston, the pressure created by this force is distributed equally to all parts of the fluid. Now, this uniform transmission of pressure is the essence of Pascal's principle. Notice that the pressure applied at the piston is felt not only at that point, but also at every other point within the fluid. The fluid particles exert equal pressure on each other, which means that the pressure is transmitted evenly through the entire fluid. This leads to the key idea that the force or pressure applied in one location can be transferred to another location within the system. Pascal's principle is particularly significant when applied to hydraulic systems. In such systems, two pistons are connected by a fluid-filled pipe. If a force is applied to the smaller piston, the pressure generated is transmitted through the fluid to the larger piston. Since the pressure is constant throughout the fluid, the force experienced by the larger piston is proportional to its surface area. In other words, the greater the surface area of the piston, the greater the force exerted. One of the most common practical applications of Pascal's principle is the hydraulic press. A small force applied to a small piston can be amplified and transferred to a much larger piston, capable of exerting a much larger force. This principle is not limited to industrial applications. It is also employed in machinery such as lifts, car brakes, and even in medical syringes. In automotive engineering, hydraulic systems are used for braking. When you apply pressure to the brake pedal, it pushes a small piston in the brake fluid lines. The pressure is then transmitted through the fluid to larger pistons at the brake pads, exerting a force that stops the vehicle. The key takeaway here is that Pascal's principle allows a small input force to generate a much larger output force, making hydraulic systems extremely efficient. Another example is the hydraulic crane. A small force applied to the smaller piston can be transmitted to a larger piston, allowing the crane to lift extremely heavy loads with relatively little effort. This is made possible by the application of Pascal's principle, where the force applied to the fluid is distributed and magnified through the hydraulic system. So, in summary, Pascal's principle is a fundamental concept that explains how pressure applied to a confined fluid is transmitted equally in all directions. This principle forms the foundation for many hydraulic systems used across industries, from automotive braking systems to large-scale industrial machinery. Now that we have discussed the conceptual foundation of Pascal's principle, let's proceed to understand how we can mathematically describe and apply this principle using the relevant equations. To analyze Pascal's principle, we rely on the relationship between force, pressure, and area. The basic equation for pressure is P is equals to F over A. Here, P P represents the pressure exerted on the fluid, F is the force applied to the fluid, and A is the area over which the force is applied. Pressure, therefore, is defined as force per unit area. Now, in the case of two pistons connected by a fluid-filled pipe, Pascal's principle tells us that the pressure exerted on both pistons is the same, wherein P1 is equals to P2, or the input pressure is equals to the output pressure. Therefore, we can express the relationship between the forces and areas of the two pistons using the equation F1 over A1 is equals to F2 over A2, where F1 is the force applied to the smaller piston with area A1 and F2 is the force exerted on the larger piston with area A2. Since the pressure is the same throughout the system, the ratio of force to area remains constant for both pistons. Now, let me present to you the steps for rearranging the equation in Pascal's principle. This will help us to determine which formula to use to solve for different variables. First, start with the basic equation. F1 over A1 is equals to F2 over A2. Second, cross multiply to eliminate the fractions. So, we have F1 times A2 is equals to F2 times A1. Next is to isolate the desired variable. So to find A1, divide both sides by F2, and then we'll have A1 is equals to F1 times A2 over F2. And to find F2, divide both sides by A1 for cancellation. And then we'll have F2 is equals to F1 times A2 over A1. And when we need to find A2, again, we divide both sides by F1 for cancellations. And then we'll have A2 is equals to F2 times A1 over F1. And lastly, to find F1, divide both sides by A2. And then we'll have F1 is equals to F2 times A1 over A2. Let's now try to solve a problem to see how this formula works in practice. An engineering student is designing a hydraulic pump to lift a crate weighing 1,815 newtons. The pump consists of two pistons connected by a fluid chamber. The student calculates that a force of 442 newtons will be applied to the smaller piston, which has an area of 0.02 square meters. What must the area of the larger piston be in order to exert the required force to lift the crate? First off is we need to identify the given values. So in the problem, we have the F2, which is 1,850 newtons, and F1, which is 442 newtons, and also the A1, which is 0.02 square meters. So the required is A2, or the area of the larger piston. So looking back at our discussion earlier, the formula that we need to use in finding A2 is A2 is equals to F2 times A1 divided by F1. Then substitute. So A2 is equals to F2, which is 1,850 newtons, times A1, which is 0.02 square meters, divided by F1, which is 442 newtons. And then after calculation, we have the value of A2, which is 0.0821 square meters. So therefore, the area of the larger piston must be 0.0821 square meters in order to lift the crate. So another example, a hydraulic lift system is being used to raise a car. The weight of the car is 12,000 newtons, and it is lifted using a large piston with an area of 0.5 square meters. The system has a small piston with an area of 0.02 square meters. What force must be applied to the small piston to lift the car? So again, we need to identify first the given values. So we have the F2, which is 12,000 newtons, and the A2, which is 0.5 square meters, and the A1, which is the 0.02 square meters. So the required is the F1, or the force that must be applied to the small piston. So the formula that we need to use is F1 is equals to F2 times A1 over A2. And then substitute. So F1 is equals to F2, which is 12,000 newtons, times A1, which is the 0.02 square meters, divided by A2, which is the 0.5 square meters. So after calculation, we have the value of F1, which is 480 newtons. So therefore, the force that must be applied to the small piston to lift the car is 480 newtons. And that is how you calculate forces and areas using Pascal's principle. And to sum up everything we have discussed, again, we have talked about the Pascal's principle, which allows us to understand and design hydraulic systems by relating force, area, and pressure. By applying the formula F1 over A1 is equals to F2 over A2, we can calculate the forces and areas in hydraulic systems, making it possible to lift large objects with little effort. The versatility of Pascal's principle is what makes it so valuable in engineering, mechanics, and other fields. And so there you have it. Until next time, thank you and goodbye everyone.